Now let's go and look at example number 3. On example number 3, they're asking you guys to rewrite the following two inequalities into a compound inequalities. We have two inequalities with an and. Remember, if it's an and, it should be connected, just like on example 2a. We're going to place the x in the middle. We're going to place the smaller value on the left hand side. That will be the -3. The bigger number on the right hand side. Now if you notice, it says x is less than 4, so that one's an easy one. On the one, it says x is greater than -3. Because the -3 is first, we are going to have to read it backwards. So it'll be -3 is less than x, which is less than 4. If you are having a hard time understanding the notation, you can just look and say, is the alligator eating the x or the -3? In this case, the alligator is eating the x. So when you rewrite it, the alligator has to continue eating the x. That will make it much easier for many of you. Let's go and look on letter B. We're going to place the x in the middle. The smaller value, which is the -7 on the left, the bigger value, the -2 on the right. Notice that this one is exactly the same. It will be less than or equal to. On x is greater or equal to -7, we are going to have to rewrite it backwards because x is greater or equal to -7. Notice that alligator is eating the x, so when you rewrite it, the alligator has to continue eating the x. Go and try letter C, pause it, and see if you guys can do letter C by yourselves. We are going to be placing the x in the middle. The smaller value is the -10 on the left, bigger number on the right. This one will be exactly the same, less than 1. X is less than -1. And on this one, we're going to flip the inequality so we can read it backwards. X is greater than -10. The alligator was eating the x, so the alligator has to continue eating the x. Just be careful. Go and read through this. This is the absolute value definition. The absolute value of a number x, written as x with 2 bars, in between 2 bars, is the distance from a number 0 on a number line. How far is each of the numbers away from 0? How many units? Many of you guys will see this in further mathematics as the notation x is equal to itself if x is positive, x is equal to 0 if x happens to be 0, and x is equal to the opposite if x is in negative. And you guys will understand the notation for the math. If you don't understand it, don't worry about it, but you guys will see the notation several times in this class, and we'll go further down the line and a little more in-depth explanation. But for now, let's go and look on the back side. We have 3 types of absolute value problems. We have an equal sign, that'll be an or. If it's less than, that's going to be an and if it's greater than or equal to, it's going to be an or. Remember, whenever we have absolute value, we're going to have 2 solutions. The first one will be x plus 3 is equal to 2, or the second one, whatever's inside the absolute value, can be the opposite and will still be correct. It will be -x minus 3 is equal to +2. And we just solve each of the equations. I'm going to move my 3 to the right, becomes a -3. In this case, I have x is equal to -1. Or, I'm going to move my -3 becomes a +3. I'm going to bring the -x down, is equal to 5. I'm going to divide by -1 on both sides. Divide by -1, divide by -1. So x is equal to -5. So my solution is x is equal to -1 or x is equal to -5. We have 2 solutions that will make this equation correct. If it's a less than, it's going to be an and it's solved exactly the same way. We have x plus 3 is less than 2, and negative x minus 3 is less than 2. We're going to solve it the same way. We're going to move the 3 to the right, becomes a negative 3. So we have x is less than negative 1. And we're going to move the negative 3 to the right, becomes a positive. We have negative x less than 5. We're going to divide by negative 1. And remember, when we divide by a negative number, we have to flip the inequality. So we have x is greater than negative 5. Since there's an and in between, just like we did on example number 3, we're going to have to rewrite it. There will be an x in the middle. The smaller number will be on the left. That will be the negative 5. The bigger number will be on the right. This one's exactly the same, so it'll be less than. This one will have to be flipped, and this will be our final solution. If it's greater than, it's going to be an OR. Very similar. X plus 3 is greater than 2, or negative x minus 3 is greater than 2. Let's go ahead and solve it. I'm now going to move my 3 to the right, becomes a negative 3. Of x is greater than negative 1. Or, I'm going to move my negative 3 to the right, becomes a positive 3. We have negative x is greater than 5. I'm going to divide by negative 1. And same as before, every time we divide by a negative number, we have to flip the inequality. So it'll be x is less than negative 5. If it's an OR, you don't need to rewrite it. It will have to be separated by an OR. But if it's an AND, remember to rewrite it and connect it. Let's go and work on example number 4. It's an equal sign, so we first have to rewrite it. It's going to be an OR. We have 2x minus 9 is equal to 15. Or negative 2x plus 9, remember that becomes a negative. Whatever's inside the absolute value has to be the opposite. It's equal to 15. And from here I just solve the equation. I'm now going to move my 9 to the right, becomes a positive 9. That'll give me 2x is equal to 24. I'm going to divide by 2. X is equal to 12. Or I move my 9 to the right, becomes a negative 9. That is negative 2x is equal to 6. I'm going to divide by negative 2. X is equal to negative 3. If it's an OR, we don't need to rewrite it. For letter B, I want you guys to think if it's this an AND or an OR. Remember, if it's less than, it's an AND. If it's greater than, it's an OR. In this case, this is greater than, so this will be an OR as well. Let's go and rewrite it. If it's absolute value, remember we have to have two solutions. So this will be 3x minus 6 is greater than or equal to 15. Or negative 3x plus 6 is greater than or equal to 15. And we're going to solve each of the inequalities separately. Move the 6 to the right, becomes a positive 6. So you have 3x is greater than or equal to 21. We divide by 3. So we have x is greater than or equal to 7. We are going to be solving the other inequality. Move the 6 to the right, becomes a negative 6. So we have negative 3x squared or equal to 9. We divide by negative 3. This will cancel. Remember, when you divide by a negative number, you have to flip the inequality. It's equal to negative 3. So x is less than or equal to negative 3. And let's place an or in between. Last example, example number 5. This one's less than, so this will be an and. We are going to have two solutions. Will be negative x plus 4, just like it is less than or equal to 6, and this is negative, so it will be positive x minus 4 is less than or equal to 6. We solve each of the inequalities separately. I'm now going to move my 4 to the right, becomes a negative 4. That'll be negative x is less than or equal to 2. I'm going to divide by negative 1. Negative and negative becomes a positive x. When I divide by a negative number, remember to flip the inequality, so I'll be negative 2. On the right hand side, I'm going to move my 4 to the right, becomes a positive 4. That'll be x is greater or equal to 10. Since it's an and, we're going to have to rewrite it. We're going to place that x in the center. The smaller value, which is the negative 2 on the left, the bigger number on the right. If you notice, this one will be exactly the same. X is less than or equal to 10. This one, the alligator is in the x, and because we're going to have to read it backwards, it will be x is greater or equal to negative 2. Go ahead and work on letter B and see what you get for your answer. For letter B, it's less than, so this will be an and. That means that once you finish, you're going to have to connect it. And also, if you graph it, the graph will be connected as well. We have 2x minus 7 is less than 4. And negative 2x plus 7 is less than 4. Remember, whatever's inside the absolute value has to be changed to the opposite. I'm now going to move my 7 to the right, becomes a positive. That'll be 2x is less than 11. I'm going to divide by 2. Divide by 2. That cancels. So x is less than 11 halves, or 5 and 1 halves. And I'm going to move my 7 to the right, becomes a negative 7. Negative 2x is less than negative 3. I'm going to divide by negative 2. This will cancel. So x is greater than negative, and negative is going to be a positive 3 halves, or 1 and 1 half. Remember, since this is an and, we're going to rewrite it, x in the middle. We're going to place the smaller one on the left hand side, which is a 3 halves, the bigger one on the right hand side. This one's exactly the same. The x is, the alligator is in the x. The way we read this is 3 halves is less than x, which is less than 11 halves. Thank you. Have a great afternoon.